Welcome student to Praveen Patil College of Diploma, Engineering and Technology Bhayandar East. Our chapter is obviously depend on chapter number 2, derivative, myself Mrs. Smita Shekhar Kamble. Today's lecture is obviously depend on very important topic, that is implicit differentiation. What it means? df upon dx, that is df upon dy into dy by dx. For example, x is equal to y square. We have to take derivative of both sides, that is both side differentiation. Derivative of x, derivative of y square. We know that derivative of x by using the formula is 1. But how to possible the derivative of y square? That means we have to take the derivative of y square into dy by dx. It is compulsory because we have to applicable the derivative with respect to x is for only x variable there. If the y variable is there, we have to multiply dy by dx and derivative of y square. We know that derivative of x square is 2x. That's why derivative of y square is 2y dy by dx. In this rule, we have to apply for implicit differentiation. For example, 2x minus y is equal to minus 3. We know that derivative of 2x is 2, derivative of y 1, but dy by dx is compulsory, we have to write. Derivative of constant is 0, therefore we shifting 2 to the right hand side, we have to derive dy by dx is equal to 2. Now second example, y raised to 5 plus 2y is equal to x square. Take the derivative of each term, d dx of y raised to 5. We know that derivative of x raised to 5 is 5x raised to 4. That's why we have to write the derivative of y raised to 5, 5y raised to 4 dy by dx. Second step, derivative of 2y is what? 2 dy by dx, derivative of y is 1 because the derivative of x is also 1. Now the derivative of x square we have to implement. X square derivative is 2x. So that's why we have to solve and simplify and equate. We have to derive dy by dx there. Now we have to take the example. X square plus 6x minus 8y plus 5y square is equal to 13. We have to take the derivative of both sides, that is differentiate with respect to x. We know the derivative of x square is 2x, derivative of 6x is 6. Why? Because the derivative of x is 1. Derivative of y is also 1, but dy by dx we have to compulsory write. Derivative of 5 remain as the same. Y square derivative is we have to apply x raised to n is n x raised to n minus 1. That's why y square derivative is 2y dy by dx. But 2 into 5, that is 10, and derivative of constant is 0. Now we have to apply 2x plus 6 is equal to, now equating part is there. We have to take dy by dx common. So, and minus sign is also common. Minus in bracket 8 plus 10y. We have to take the minus symbol of common. Both sign will be changed because it is shift in this side. So that's why minus become plus, plus become minus. Dy by dx remain as the same. This term remain as the same. Now 8 minus 10y is in a multiplication of dy by dx. So dy by dx remain as the same. 8 minus 10y goes to this side. So in this way dy by dx is equal to 2x plus 6 upon 8 minus 10y. If we have to take 2 common, then 2 in bracket x plus 3 upon 2 common, 2 minus 10y here is there. So it is 2 common we have to take. So it is 4 minus 5y. So in this way x plus 3 upon 4 minus y. So now derivative of y square plus xy is equal to d dx of 10. We know that 4y cube upon dy by dx plus x dy by dx plus y is equal to 0. How it is possible? Yes, we know that y raised to 4 we have to apply x raised to n derivative is n x raised to n minus 1. That's why 4y raised to 3 minus 1 dy by dx remain as the same. X into y derivative, x derivative of y plus y derivative of x. U into v rule we have to apply. What is u into v rule? Yes, derivative of u, no, it is u derivative of v plus v derivative of u. That's why this expansion is possible. That is product rule is applied. Now the equating part is start. Dy by dx we have to take common. What is remaining? 4y cube plus x is equal to minus y. Now we have dy by dx is equal to minus y upon 4y cube into x. Now 2x y cube plus x square 3y square into dy by dx minus x dy by dx. Suppose it is the term, we have to simplify. Yes, already derivative is taken, so we have to simplify. How equating part is discussed? Yes, we have to take dy by dx from this term common. So what is derivation? That is 3x square y square dy by dx minus x dy by dx and 2xy cube and minus y shift this side. So it is plus y and minus 2xy cube. In these two terms we have to take dy by dx common. That's why 3x square y square minus x dy by dx is equal to minus y minus 2xy cube. In this way, dy by dx is equal to y minus 2xy cube upon 2x square y square minus x. Therefore, dy by dx is equal to 2xy cube minus y upon x minus 3x square y square. In this way, we have to take the derivative. Now we have to show that x square into y square x plus y raised to bracket 5 show that dy by dx is y upon x. So equating part we have to take and we have to take the derivative there. So in these examples we have to discuss about the constant is 0, power rule is x raised to n is equal to n x raised to n minus 1, product rule derivative of f of x into g of x is equal to f dash of x into g dash of x plus f of x into g dash of x. Quotient rule derivative of f of x upon g of x is g of x into f dash of x minus f of x into g dash of x upon g of x bracket square. Now chain rule derivative of f in bracket g of x is equal to f dash of g of x g dash of x. So I want to revise the implicit differentiation again. We have to take df upon dx is equal to df upon dy into dy by dx is equal to x y square derivative of x is 1, y square derivative is 2y dy by dx. In this way we have to take the derivative of implicit function. How it is possible? X square minus 3xy plus 4y is equal to 0. Differentiate separately. We have notation we have to use is y dash. Y dash is used for instead of the dy by dx. That's why we have to take y dash for dy by dx and x remain as the same. Derivative we have to possible. Always remind that notice we have to use the differentiation rule for the example which we have to consult in the examples. So in this way we have to take the derivative of that. Interesting part is there. We have to take the derivative of ln x is 1 upon x, derivative of f of x 1 upon f of x into f dash of x, derivative of log x to the base is 1 upon x ln a, derivative of log of f of x 1 upon f of x ln f dash of x. Be careful in derivative formula we have to must change about the implicit function. It is possible to derive the above expression in the form of the example which take the allotment of y square variable and x square variable which are corresponding to their logins. Now we have to take the example based on these implicit function. In this way how it is possible? So we have to take suppose the derivative with respect to x there is. So I want to revise this example in the form of the derivative which not considerable, we have to think about that. So implicit function, and in this pattern we have to must discuss about the variability which varies and implement to the given as a implicit pattern. We have to must know that the y variable is different for the x variable, which is impossible to find derivation. So in this way we have to differentiate and implicit the differentiator. So with respect to x, it is how much and how variability is possible to concern by today's lecture. So today's lecture is over to implicit function differentiation. So thank you very much, student.